I welcome you once again to this physics class. As you can see on the board, we'll be considering projectile motion this morning. I know we have learned about different forms of motion, but emphasis this morning is actually going to be on projectile motion. Please take note of the topic, projectile motion, because in this topic we have two words, projectile and motion. So when we are defining projectile motion, we are actually talking about motion of a body that is launched into the air and allowed to fall freely on its own. That is what we mean by projectile motion, motion of that body. But when we talk about projectile, we are talking about the body in question that we are launching into the air and we allow that body to fall on its own. That is what we mean by projectile and also projectile motion. Having said that, most textbooks, when you consider them, they try to treat this topic differently, but for the benefit of this class, I decided to just bring everything together so that we'll be considering under projectile motion, vertical types of projectile motion, horizontal type, and the so-called projectile that many textbooks emphasize, and that is parabolic type of projectile motion. So we have types of projectile motion. Number one, vertical. We call it just vertical projection to save time. Number two, horizontal projection. And number three, we have parabolic projection. So we pick these types one after the other. For the benefit of today's class, we just look at vertical projection, and if time permits, we also consider horizontal projection. When we say vertical projection, we're actually talking about a body that is launched into the air vertically, and then the body also comes to the ground vertically. So most textbooks call it motion under gravity, but I've decided to treat it as vertical projection. So in vertical projection, basic thing to note, just like in our normal equation of motion, we were taught three different types of, three equations of motion. The first one being equation of motion, equations of, let me just call it equations of vertical projection. Equation 1. Equation 1 says V is equals to U plus or minus GT. When we say a body falls on its own, we are talking about a body falling under the influence of gravity. Take note. Now, if a body is launched into the air, the acceleration due to gravity of that body will be minus G is equals to negative for upward projection. And when we have this type, G is equals to positive when the body is coming down. So take note of that. We have it as plus if the body is coming down to the ground, but it is negative when the body is what? Going up. With this expression, we can actually come up with formula for calculating time that the body uses to get to its maximum height. When the body at maximum height, what we are expected to have is at maximum height, V automatically becomes 0. When we launch a body up, as the body is increasing, Then the body is reducing its speed. When the body gets to the utmost height, which is the maximum height, the speed automatically becomes 0. And then we can determine its time at that particular point. At maximum height, v is equals to 0. So we can have 0 is equals to u. Yes, I said when the body is going up, automatically the emphasis will now be minus. Because I said when the body is going up, our g is what? It's negative. Don't forget that. So we have g is equals to 0 is equals to u minus gt. So we want to make t the subject of the formula here, and then we have gt first. If minus gt comes to the side of 0, it becomes gt. And when you add 0 to any number, the number retains itself. Gt is equals to u. So that our t from here is equals to u all over g. Take note of that. This t in question is small letter t because it is just the time for the body to get to its maximum height. Now, the same time that the body uses to get to maximum height is also consumed, so to say, when the body will return back to the ground. That one we call it capital letter T. And this capital letter T is actually referred to as time of flight. That is the time taken for the body to get up and to return to the ground. This time of flight is just twice the time taken for the body to get to the maximum height, and that is 2t, which is also equals to 2u all over g. Take note, this is the time taken for the body to get to the top and to also return to the ground, capital letter T. Why small letter t? Time taken for the body to just get to its top. Now, equation 2, this equation 1 of motion. Equation 2 says S is equals to ut minus half gt squared. I'm just considering a body that is going up now. I'm not really interested in what happens when the body is coming to the ground. So we want to determine this S. Now, this S in question, we can actually, majorly, whenever they want to emphasize anything on this S, we always use it to determine the maximum height. So for maximum height, S automatically will become H maximum. So we want to establish the formula for maximum height in vertical projection. So where I have S here, I can actually replace it with H maximum. So just for the sake of the class, I'm just going to use H subscript M. Hm, which represents maximum height, is equal to ut minus half gt squared. So from this end, don't forget we have already obtained the value for small letter t in our first equation, where t is equal to u all over g. So if we substitute this t into this expression, we come up with hm is equal to u into bracket u all over g minus 1 all over 2 g. This one we have u all over g, then square. And this will give us u square all over g minus, this 2 is a denominator. So g here is up, the 2 is down. So I have g u square all over 2g squared. 1g will remove one of the g down. So we have u square all over g minus u square all over 2g. And when you have an expression like this, we can actually find the LCM of these two terms. So LCM here is 2g. G into g will give us 2. 2 times u square, I have 2u square, minus 2g into g, I have 1. 1 times u square, I have u square. These two terms in our numerator, we can actually subtract them because they are like terms. So it's more or less like saying this u square is having its coefficient to be 1. So I can take 1 u square, it's like saying 5 naira minus 4 naira. It is possible to produce answer. Not like when you say 5 naira minus $3. That is not possible because of the unit. The two of them are carrying u square, so it is possible to remove u square from 2u square. If we take u square away from 2u square, we have our H maximum to be equal to u square all over 2g. Take note, this is the formula for calculating our maximum height under vertical projection. Let me at this point in time address this u in question. This u in question is vertical component of view, because I've said the other time that we are dealing with vertical projection. It is possible to have horizontal component of view, but for this expression or for this consideration, our u here is our uy. Take note of that. So most times I prefer to specify that y so that you can actually take note of that. So most times if we just put it as u square over 2g, but for your own what's it called interest, make sure you have it as uy square. It's just to define the types of projection we are dealing with here, and that is our uy. So we have this. If I consider the third equation of motion, one thing to just note here is that we are still actually making use of third equation of motion to determine maximum height most of the time. So take note of that. So I will just give a question and then we solve that one question, and then we just round up for today. So yeah, I believe you can hear me. Let's consider this example. An object falls freely from a height of 25 meters onto the roof of a building 5 meters high. An object is falling from a height of 25 to the top of a building whose height is also 5 meters. Then the question is asking us to calculate the velocity with which the object strikes the roof. Emphasis is just on the roof, not on the ground. So take note of that. So it is important to always identify the data specified given h of the object from the ground to be 25 meters and h, which is the height of the building, to be 5 meters. And then the question, yes, even though we are not really giving the acceleration due to gravity, but most times when you are not giving, just know that the value is always 10 meters per second square. So if you are not giving, otherwise, just make use of the value given. But if you are not giving any value, you can make use of 10 meters per second square to calculate your question as value of g. So the question is asking us to calculate the velocity with which the body strikes the ground. That should be our final velocity. Final velocity. Now, analysis. This is more or less like picture of what we have. That's the height of the object. This is more or less like the building. I'm just trying to sketch. Take note of that. Let me just take this as the building. The height of this building is our h, given to be 5 meters, but the height of the object to this roof where the building is given as capital letter H, and that is what? No. Take note, sorry. The height of the object to the ground. This is the ground. The height of the object to the ground is given as 25 meters. But our interest is the height of the body to the roof. So this is h minus h, and that is 25 minus 5. That will give us 20 meters. So it is this 20 meters we actually want to use to determine our velocity. Take note. Now, when you are given a question like this, it is important to first look at our equations and try and identify if the equation one can actually work based on the value given. So equation 1 of motion. Now, I've told us earlier that when a body is released into the ground, the G value will be positive. Don't forget that. But if the body is launched into the air, G value will be negative. In this case now, our object is released to the ground, so G is expected to be what? Positive. So if I consider equation 1 of vertical projection, which is U plus GT, in this expression, even though this is what we are looking for, V, but we are not given anything that has to do with G. We have nothing concerning the value of T. So equation 1 cannot be used. So take note of that. Equation 2 also, S is equal to UT plus RGT squared. If you look at equation 2, our unknown, what we are looking for is not even reflecting there. So equation 2 also, we cannot make use of it. But let's look at what equation 3 says. Equation 3 says V squared is equal to U squared plus 2G S, where this X is equal to my H minus what? H, and that is what? 20 meters. Don't forget that one. Now, before the body is released, we believe that the speed of the body initially is 0. The body is initially at rest. Take note of that. This is what we are looking for. So when we substitute our given value, so we are going to have V squared is equal to 0 squared. Let me specify that somewhere here, where U is equal to 0. 0 squared plus 2 multiplied by 10 multiplied by 20. So I have V squared is equal to 0. 0 squared will give us 0. I believe you know that. 2 times 10, 20. 20 squared will give us 400. When you add 0 and 400 together, you will produce your 400 back. So to find our V now, we move this square to the other side of 400. That will become square root. Square root of 400 will give us, ideally, if it is in mathematics, we say plus or minus 20. But in physics, emphasis is just the positive value that we are interested in here. So we just pick plus 20. Don't forget unit of your velocity, that is meter per second. So take note of that. So that is one example. Okay. So I will just try and solve one more question for the benefit of this time, and that is a question where we are looking for T, small letter T. Now, let's take that example down. A mango fruit drops from the top of a tree, 45 meters tall. How long does it take to reach the ground? A body is released from the top of a tree of height 45 meters. The question is now how long. Whenever you hear a question that says how long, we are looking for time. If you hear a question saying how far, we are looking for distance. But if your question says how fast, we are looking for speed. So take note of that. So in this example 2, given we have our H given to be 45 meters, and then we have G 10 meters per second square, and then the question is asking us to look for how long is our T. So take note of that. If we say how long, now in this instance, if we make use of the formula we have written before, we are looking for T. Here we have nothing to do with, we are not giving anything that has to do with our age, so we cannot use equation 1. We cannot make use of equation 3 also because V is not given. We can only use S. So equation 2. Equation 2 says H is equal to UT plus half GT squared. Take note of that. Before the body is released, our U is assumed to be 0. So we can actually fix in all the given value to obtain the unknown. So if I put 45 here, I will have 0, T plus 1 all over 2, 10 t square. 45 is equal to 0 plus, if you cut 2 and 10, you have 5t square. So this gives us 45 is equal to 5t square. So what do we do? Divide both sides by 5. By 5. This will give us 9. So we have t square is equal to 9. So your t will be square root of 9. And that will be what? 3. I believe you know the unit of time. That is 3 seconds. So, as you can see, time is not really on our side this time, or this moment. So we have to just wrap up or end the class at this point. We will consider horizontal projectile in our next class. Trust God that in our subsequent class we will finish with projectile motion. Have a lovely day.